Greetings, Professor Q. This is Group P25, and this is our IoT project. Our group leader is Azari, and the members are Qin Cheng, Owan, Rudy, Danzel, and Sriram. The flow of the presentation are as follows. The chosen field of our project is the automation of chocolate manufacturing, specifically the packaging process. As a brief background, Willy Wonka's chocolate factory workers are undergoing stress and an overload of work. There are too little people doing too many tasks. As a result, there is reduced work efficiency, reduced profits, and employees' welfare is taking a hit. Therefore, the company decided to incorporate IoT to assist the workers and reduce their workload. The team decided to conduct research looking for how automation would affect food manufacturing. Based on a research paper done by Caldwell, it is found that automation in food processing brings about fast operational speed, efficient inspection system, improved work conditions for the workers, and consistent quality of products. The current operation is as shown. 2 workers were taken as an example, Oompa and Loompa. Oompa oversees manual inspection. His job includes manually measuring the temperature of the work floor, updating measured temperature into a logbook, and controlling the servo motor which controls the conveyor system of the packaging process. Whilst Loompa tasks include counting 10 boxes in each pallet and transferring a pallet of boxes to the shipping section, recording the count of total boxes packed, and raising alarm to Oompa when there is a miscount. These tasks overload the workers, which affects overall production. As shown, Oompa's constant hourly temperature checking increases the risk of human error and affects chocolate quality. Any temperature increases between checks can harm chocolate quality. If suboptimal temperatures are detected, there is a delay in stopping the conveyor belt via servo motor. Hourly temperature checks lead to frequent pauses in conveyor belt operation, impacting production efficiency. For Loompa, continuous manual counting of boxes for each pallet is required, with manual transfer of pallets after reaching 10 boxes. Loompa must inform his colleague to stop the conveyor before transferring. Additionally, manual recording of manufactured box counts is necessary, with alerts to halt the conveyor if totals do not match, increasing the chance of human error due to reliance on another worker for conveyor control. Therefore, the proposed IoT solution to solve this problem is to make use of sensors and actuators to automate certain processes, thus relieving certain tasks from Oompa and Loompa. As shown, a touch, light, and temperature sensor are used, but for actuators, an LED indicator, an LCD indicator, and a servo motor is used. To connect all these sensors and actuators, ThinkSpeak is used for cloud storage, MQTT is used as a bypass for faster transmission, and Wi-Fi for connectivity. As an illustration, this slide shows the use of each sensor and actuator and how they are interlinked. Now for the sensor and actuator allocations. Rudy oversees the touch sensor. It has a refresh rate of 2 seconds, and the I/O table is shown below. The usage of the touch sensor is crucial in the manufacturing process, as it controls the flow of packing. If a pallet does not activate the touch sensor, the operation halts until a pallet is detected. The sensor operates on simple Boolean logic, distinguishing between detecting a pallet true and not detecting one false. Next up, Qin Cheng oversees the servo motor control with a refresh rate of 6 seconds. The I/O table is as shown below. The servo motor acts as a control of the conveyor belt, controlled by MQTT app signals and integrated with temperature and touch sensors for efficient automation. The system promptly detects and addresses production changes or unexpected events like blockages, reducing downtime, enhancing productivity, and ensuring reliable conveyor operation. Next up, Danzel oversees the LCD indicator and the usage of the MQTT app. The LCD indicator has a refresh rate of 5 seconds. The I/O table for the LCD is as shown. The LCD output displays real-time temperature and production metrics. Monitoring temperature aids in maintaining chocolate quality by enabling immediate response to temperature changes. Additionally, real-time tracking of packed boxes and pallets enhances operational visibility, facilitating efficient production planning and coordination. The MQTT app serves as the primary power source and enables swift execution of safety and operational commands, particularly for controlling the servo motor. Its efficient message delivery ensures real-time execution of commands, enhancing response times during critical situations and reducing the risk of accidents or equipment damage.
A1 was in charge of the LED output that has a refresh rate of 2 to 5 seconds. This is its I/O table. The LED has 3 indications: blue light for when the pallet is full of boxes, green light when the conveyor or the servo motor is running, and red light for when the conveyor or servo motor is not running. Sriram was in charge of the temperature sensor with a refresh rate of 15 seconds. The I/O table is as shown. The temperature sensor monitors the surrounding temperature and sends a signal when temperature hits suboptimal levels. Azari worked with the light sensor, which has an update rate of 1 to 3 seconds. Below is the I/O table. The light sensor is used to count the pieces of chocolates. Using light sensors ensures precision as they are highly accurate in detecting the presence of objects passing through their light beam. The team had a handful of key innovations that would greatly help Oompa and Loompa. The team decided to use MQTT to integrate IoT. This allows for higher accuracy and efficiency. The real-time communication between the various components would alleviate the need for Oompa and Loompa to communicate when there is a miscount. As the servo motor controls the conveyor precisely, Loompa is not required to stop the conveyor as it would be automated. The touch sensor's strategic placement would allow the conveyor to automatically stop once the pallet is removed when it's full. The temperature being displayed at all times will allow for Loompa to always have access to what it is. The count would constantly be updated in the cloud, allowing Loompa to cross-reference and check at any time. Lastly, the RGB lights also serve as an additional indicator in order to remind the operators of normal operation or if there is a missing pallet. There were a couple of challenges that the team faced. Firstly, the coding was a challenge, and it showed us that using MQTT was the better option to handle the multiple signals from the various components. Secondly, the team also took time to familiarize ourselves with the components given to us. The team also found it challenging to pinpoint errors when it came to faulty equipment. Lastly, the team had issues reading and writing through ThinkSpeak. The team was successful in using MQTT as a broker to publish all of the team's components' values to ThinkSpeak. The team was able to successfully integrate the components, allowing them to communicate and deliver favorable outputs. In summary, the IoT implementation consists of a sensory network equipped with touch, temperature, and light sensors to gather environmental data. The data is then used for automation through actuators such as servo motors, LCD indicators, and LED indicators, which respond to the conditions detected by the sensors. The system utilizes ThinkSpeak for cloud storage, storing values from the sensory network and actuator logic. Additionally, remote access and control are facilitated through an MQTT app, allowing users to monitor production metrics and control the packing system remotely. For future work, the team thought of adding another servo motor to automate the process of removing the full pallet and replacing it with an empty one. However, we did not have the components to do so. Secondly, adding an audio signal such as a speaker when the conveyor stops moving was also another improvement that the team thought of. However, due to shortage of resources, we were unable to incorporate it. Finally, these are the references used for our research. Thank you.